I teach just north of the suburbs of Chicago in Wilmette, Illinois. I just want to share tonight just some updates of writing the new earth science curriculum for the middle school level, and I hope that you'll be able to adapt this to if you're a high school teacher for that. And there's a small group of us here tonight, so feel free and just hop in, ask a question, or throw a question in chat, or just ask me questions. Or if I'm screen sharing and I'm not screen sharing the correct thing, please just let me know if I'm not yet following it. Just to go through real quick, if you guys want to take a look at our social media for AMTA's social media platform. A big one that I use to stay in touch with other junior high modeling instructors is the Discord one. So Discord is one that definitely a lot of chats get thrown on there and people ask questions or sharing resources or asking for resources. And then another one I really like on the bottom is the science modeling talks. They come out on the first of every month. If you're not familiar with that, you can subscribe to that through the podcast. I've run one week workshop on earth science, and it was like 2021 with another high school earth science teacher named Stephen Colbert. If you definitely want to reach out to him, he made this really nice diagram while we're doing the workshop of what are some underlying principles that we have when we're teaching earth science. And it's almost like a continuation. I feel like it's like a practicum, like a continuation of physical science, where we start with particles and how they're in motion, and that really helps us to describe phenomenon I have with our geology units and weather and climate. And with that, a lot of it is thermal energy, how it's stored, how energy transfer, and the different parts of that. And a lot of it's just being implemented with it there. If you want a link to this handout, I'm going to send in the email afterwards a couple of things, but there's a link also in the slides to this paper if you want it. It's just a graphic organizer to help kind of talk about our overall models that we're building in the earth science curriculum. How I set up the earth science curriculum for the junior high is we were talking about developing models. And with me, with the model development it's like a story where one activity leads off the next, and throughout that we're building and revising our models. So this is a one I made from a long time ago, one with the sixth grade chemistry unit on water chemistry, where I actually have it like kind of like a path, and like we have our major concepts, and I drew diagrams to show the major development as our model as we go. So when I just walk you through the units that we developed, it's just kind of talking you through. I'm just going to show you the earth science. I wasn't really sure how to present this tonight and trying to get it all done in, I don't know, 30 minutes to an hour. I don't know how long this will take. How I set up how the curriculum flows from one activity to the next with that. There were 4 units that we developed in the spring and the summer. There's a plate motion unit that also leads into the rock cycle unit. And then also I have an oceans and climate, which the climate unit then builds into weather and storms. So I'm going to move to, I'm not sure. Stu, can they see a Google Doc right now? Can you
Yeah.
see a Google Doc? Cool. All right. So these are the teacher notes that are posted on the AMTA website. So I'm just going to talk you through each unit. And by all means, if you want, again, like just ask questions to a small group, or if you want to throw things in the chat, by all means with that. This table here is set up, the summary table. It gives you like an overview to the unit. But I also started doing a thing where when I was reading ambitious science teaching and some of the articles afterwards that the ambitious science teaching mentions with implementing NGSS is the summary table. So this is like a teacher version of a summary table. Afterwards with this unit, I'll show you an example of what students do. And I feel like the summary tables have just been a really good way to really scaffold and really set out the unit, how we develop our models throughout the unit. The unit from here I start with this phenomenon where it's a YouTube video of a scientist, and he's talking about how they find ancient sea fossils high in the mountains when there's no recorded history of running water or anything being there. With that, then I always start with an elicitation activity where it's almost like a pre-test for students. I tell them like, well, if we have our phenomena is how are sea fossils found high in the Rocky Mountains when there's no recorded history of them. I get an elicitation then of getting students, all of them, to whiteboard and get in a circle talking about like what's their initial predictions there. And I'm not telling them if they're right or wrong. And having students just get their starting ideas. Some students, like out of my 7th grade students, like 1 or 2 students will start talking about plate motion. They don't usually give much of a detailed version of that or like how it works. They might mention Pangea, but they're not usually able to expand a whole lot on that. And even if they bring up, like, they're gonna have 6 or 7 groups with all sorts of preconceptions. If they have a good idea how to start, I still, like, I used to panic right away where I'm like, oh my gosh, they know too much coming into this. Like, I'm not gonna help them out. They still learn a lot throughout the unit and enjoy it. And with that, then I'm still just staying not like non-reserved during that. The first activity then is we talk about, I first start the first unit is it's an activity where they talk about core sampling. And with this, then they talk about what core samples are and how we can look into the Earth's history to try to start to begin. Like, if these ancient sea fossils are millions of years old, how do we know that? If I scroll really far down below, in the teacher notes, it shows you, like, I actually do an activity with Play-Doh. There's 2 versions of this. There's a worksheet, or you just have them drill down. And with this, then they start to see that it doesn't matter where you drill along the earth, they're always going to find this one in the key. They'll find that the red Play-Doh is hard solid volcanic rock. And we start to explain, like, that's a pattern that we're going to continue to investigate throughout the unit. Next thing we move into then is if we're finding hard solid volcanic rock. And again, like, all these things here, like how activity one leads to another, like, I try to be brief here in the summary table here, but if you scroll down further, it expands more on the activity and how to do them. I used a lot of activities from the Concord Consortium. It's a free simulation. You don't have to have a subscription to it, but this one does an awesome job where it has volcanic and earthquake data. I'm not sure if you've seen this before, but again, it shows like over millions of years. There's a worksheet to go with this to look for patterns and data with that. Another cool thing with this simulation is you can actually draw cross sections here and then have you actually open it up and look through it, and analyze and interpret data. My worksheet for the students at the junior high level is a lot simpler. But all they're doing is they're starting to use like cross sections, side views of our diagram of the Earth is important patterns to see what's going on inside the Earth. And we start to look at earthquake data. Then this leads me into a couple of a lab where we do the Slinky lab with P waves and S waves. I can attach a video if you want afterwards or anything, but we talk about how when earthquakes happen, when they release P waves and S waves, we can see a pattern here to see how scientists use this data to figure out, because they get out of the simulation of where earthquakes and volcanoes happen at plate boundaries. Now we start talking about seismic data to help figure out where we can locate these plate boundaries. The simulations we have here, these are really good. It's Explore Learning or Gizmos. It's a paid subscription. You can get a 30-day free account, but then afterwards it'll lock you out. But there's some really good simulations here. We're talking about, like, hey, how we use seismograms to figure out where these plate boundaries are, because we start to see, like, that's where the Earth's surface is changing. Afterwards, then we start talking about after we talk about the seismic data, there's a really cool app that's free, because not only do we locate where plate boundaries are, but there's a thing called the HAMS seismograph. If I can get this correct. Oh, I don't think it'll let me. This is free on the App Store. And with this then is you can download it. My students do it on iPads. If you want, you can have your students do it on phones. But it's cool is because if you tap if you put this over different substances like water, I have my kids lay them over their iPads over sand, water, or gel. You tap on it and you start to see that how on the side next to the bag, whatever it's that the waves look differently as they travel through different things. So I connect that back to that we see that waves travel differently through different materials. So then it leads us into another simulation where we see where we have seismic waves, how they travel through. We know they look different through different materials. So this is really cool. This is a free sim also, is where we see, you click seismic waves, and we have our epicenter here. And we talked before with P waves and S waves with those active prior simulations. And they start to see how P waves and S waves travel through the Earth's surface. and they see how they reflect back can tell us based on the previous activity, like how they reflect back, this is how the wave looks. We can infer what the each layer of the earth looks like. And that's just to get the students to understand, like, we haven't really drilled far into the earth. We talk about that before. But with this then is we see that, yeah, this is how we know what the inside of the earth is. So that can begin to tell us to figure out how plate boundaries work. So I have them stop and I have them do a midpoint check at this part. And I know it's small in the teacher notes, but it just tells us, like, what do we know about the Earth's surface? What do we know about the Earth, the surface right now? And with that, then is now we know what the inside of the Earth looks like and why we see a lot of volcanic rock all over the Earth. So then I have them do a lab where we actually have them. There's a convection jar, and all the materials that you need for this are posted down in the teacher notes. But we start to see that it flows in a convection cycle that can help make the Earth's surface move. I try and be careful here about the misconception. I also show them a little video with convection cycles and also the slab pull that's moving the plates, that's causing the plates to move with that. And with this, then afterwards, then we go back to is another free simulation where we start to get into plate motion and plate movement, where you can actually draw the land. And then if I go to the next part, you can actually make what type of boundary you want, a convergent or divergent. And then, yeah, and you start to see how the plates are moving, and you can even draw a cross section again to analyze what's going on at the plate's surface. And it gives you a key. There's a lot going on here. And with this, then also as it's going, you can start to see volcanoes and earthquakes. One misconception you try to get out of here is it earthquakes and volcanoes that's causing the plates to move, or is it the other way around, or is it how the plates are moving is causing earthquakes and volcanoes throughout that part? Another good free simulation there. I implement some readings on here. I just don't want to take the time with this, but there are free readings here that you can just open up. I use it with the curriculum that I have, and it helps expand on what they've already talked about with these other things, with the previous simulations and labs. Another one is the Pangea simulation. This is another gizmo. It's another explore learning one. You have to have a subscription to it. But if you have other activities, like the teachers next door to me, when they teach Pangea, they have them do the cutouts and match up the fossil evidence and try to help students build how Alfred Wegener developed his theory of continental drift with that. At the end of the unit, we talk about evidence of Pangea here. And with that, then there is an evidence card sort, and I like doing evidence card sorts as a way to review. There's multiple different evidence cards here, and basically you have to rank them weakest to strongest for what could Pangea had existed. And there's some controversial cards here, like they have controversy over which one's stronger evidence for Pangea existing. And a lot of teachers have a lot of like being like when the kids circle up with their whiteboards. I have them use thumbtack. They actually these are all cut out, and then they have thumbtack them to a wall. I wonder if I have an example of it. Oh yeah. So like this is I don't know if it's too small, but they're thumbtacked to the board, and then they're ranking them. So the more controversial, when the students start arguing over which one's more stronger, I feel like that's where the students are doing more sense making here. And it leads to a better discussion. And again, these this handout is also attached on there. So at the end of this unit, they have, and I know it's too small with this summary board, but they talk about what they know about the Earth's surface and talking about fossil evidence and all about plate boundaries to help them figure out like how they know why ancient sea fossils got to the end, because then they know it's plate motion, what's causing the plates to move, and that they know it's a convergent boundary that moved the fossils high up in the mountains. If you like I said, like I've been talking about the other things, like I'm just kind of recapping here with these teacher notes. Like it lays out here where the simulations are linked, the worksheet. Also, if there's equipment that you need to buy, they're also posted on here too. The materials are posted here too. Like here's the ham seismograph. Here's how you use it. It's a small group. Does anyone want to have any questions about this unit, or anyone want to throw anything in the chat? If works in the course that. Oh yeah, thanks, Connie. Yeah, there's a worksheet. Yeah, there's also, yeah, again, Concord has a whole plethora of worksheets too to help you use it. This is just what I just use what helped me work with my students with that. So okay. I'm gonna move to, and again, like this summary table afterwards, like this is a teacher version. Here's actually one that my students made this year. And they like to, I give them this a blank template where the phenomenon and the questions, I usually have guiding questions throughout the unit, but we usually journal then afterwards as a class where we'll take the activity of it. They'll take a picture of their whiteboard or a whiteboard that they like from the other groups. And then we talk about what was the most important during our discussion and how does it connect to the big picture of the unit? How does it develop our model? So like this is the unit, this is the one with core samples we did with Play-Doh, the volcano earthquake data. We use the Slinky lab, some of the amplify, like, yeah, here's the sand, water, and gel. The sand, water, and gel, like they looked different. The waves looked differently. Again, like this is just something like this unit took me with my kids this year about 5.5 weeks. And they usually, again, like they're just usually big artifacts of things like a new idea. We only journal usually when we usually have a new idea here from it. And then this is usually a blank template that I gave them to start the unit with that.
George, can I ask you a question on that template?
Yeah.
So you just said this is a blank one that you give them. Um, do you happen to have a copy of that in the curriculum?
Yeah,
Or
you know what I will do is I'm putting in my notes
okay,
and I will put it in, I'll send a mass email out with a survey about this webinar, and then I will put the summary table template for you afterwards.
is this done on a individual basis? Is it done as a group?
I do it. We do it as a class. I have
Oh, okay,
seventh graders. I don't have the right or wrong way. It's just what I do in my room. And
that's
my
fine.
administrators have critiqued me before, saying they want the students to do it on their own. And my seventh graders, like I have really sharp seventh graders, like really smart kids. They really struggle to fill this out. So we usually talk through as a class. Like we'll sit down. They'll know to what the title activity is, and to put a picture of the whiteboard. And then we'll talk through as a class what was the most important thing when we circled up in our whiteboard discussion and how does it connect to the big picture. It's
Okay,
not a lot. It's usually not a lot of writing. It's just kind of like right to the point.
okay.
My seventh grader struggled doing this individually. We'll have a really good discussion, but yeah, after them journaling after this, I'm not, yeah, this has been tough. I've been doing summary tables for about like 5 or 6 years now. Um, but yeah,
Okay, great. Thank you.
yeah. Um, I will go to the rock cycle unit, and I'm actually just starting this unit. It's probably this Friday. There's a YouTube video, and it's a guy in Colorado, and he's just talking about these rocks are made of the same types of minerals, but they all look so differently, the same stuff, but they all look so differently. Again, like this is just an elicitation that I start the unit with. It's like a pre-test for them. And I just want to see their preconceptions of why they think they look so why they look so different when they're made of the same stuff. Um, I also lay out rocks for them in trays, basalt, conglomerate, sand, granite, and have them just start making like just have them say start referencing rocks and things like that. And that's just a preconception. We do the afterwards, we do the traditional hopefully I'm saying right, the Mohs test, the rocks and minerals one. And it's just to get them used to knowing that just getting them just like talking about minerals. And I really am trying to get throughout this is that minerals are more a pure substance, and then rocks, trying to get them to realize the difference between rocks and minerals. And with my seventh graders, like I do the lab, we do a reading afterwards. Um, but still, yeah, trying to get them to understand that the rocks are all made of the same types of minerals in Colorado, but they look differently. So again, like just starting slow with our model development here. Um, there's a forming rock cycle. This one's cool. This is again like a free one from the Concord. Built it in then is that then they're using going back to our plate boundaries, but then they're actually when you drew these things, like it actually you have them yeah, have them then that you can actually when you roll the sim, you can make different types of rocks. And that's yeah, I'm gonna try and draw the boundaries. I think yeah, but basically throughout here you can make it, yeah, make different types of rocks. And Um, there's a little bit of an analysis with that. And then when you draw the cross section here, yeah, this is cool with the key, which I'm not sure where it's at, but you can do that. Yeah, it'll show you the types of rocks being made and introduce these things like igneous, metamorphic, and sedimentary. But yeah, with that. So we got start seeing this idea that there's igneous, sedimentary, and metamorphic. We do some readings where we start talking about how they're made, how the igneous, especially this one unit, really just focus on how igneous and sedimentary are different. Um, there's one where I do here, and this is in teacher notes, igneous sedimentary worksheet. It's a lab where, and it's in the notes, but they make igneous and sedimentary out of Jolly Ranchers. The instructions show you how to make them there. And even though they're both made of Jolly Ranchers, they look really different at the end. And they start seeing that it's really the process that makes them look, how the formation of them makes it look differently. There's a gizmo here. This is kind of just an application extension, but this is a good one where they have to sort the rocks by their appearance and identify if they're igneous, sedimentary, or metamorphic rocks. Again, that is a paid subscription. Is it essential for the storyline? Not so much, though. They have an assessment here then at this point on the types of rocks. Afterwards, I'm always trying to do more graphing labs and extensions with these with it. There's a weathering lab here where they actually take different sugar cubes and they use different ways how to weather them. There's somebody I make them dissolve at different rates. They change the temperature. They can change the acidity. I think I forgot which ones we put in, like vinegar, a couple different variables, and it's just a way to just try to get the kids practicing their graphing. Have some readings here. Again, there's a simulation here again where they go back and also help explore in depth more. This one, even though they're making they're using the same simulation again. Now we're talking about energy and how it works in there. Talking about now it's the Earth's inner, and not even the Earth's inner core, but also like weathering sun plays a huge part of this, different energy sources. And with that, they use that to apply here, which I like then, is they start using the particle diagrams with here, how they use the energy bar charts here. They use a particle, they start studying particles, and then they use that for energy bar chart worksheets. This one's pretty simple, right to the point, but when they use just trying to always try to have these energy bar charts go throughout our unit. We're only talking about thermal energy at this point with my junior high kids, with that though. So yeah, and then afterwards, yeah, there's just a little diagram. They make a cross section and they have to explain how two different rocks look differently. I give them a sedimentary rock and an igneous rock, granite, and I think it's conglomerate I give them with that. Again, like the worksheets, all that, the more in-depth notes with that are also go in line here. So this unit will, like, here's like how to do the Jolly Rancher lab with igneous rocks and sedimentary. This unit's a little bit faster. Like here's our weathering lab, but I don't know if they changed the temperature here, what their independent was. Yeah. And then yeah, this unit is much faster. It takes about like 3.5 weeks. They're just continuing to know what they know about plate motion and then how that works with that. So I'm not sure if anyone has any questions about our rock cycling unit. I was just going to talk about the last two units, our climate and weather unit and storms with that. So same thing with our weather unit. Again, summary table is done here. Elicitation. I think what is my intro for this one? Oh, it's just talking about, yeah, why is the ocean flowing in these sorts of patterns? And I really use in this unit with my students. This is a longer unit. This almost takes like 6 weeks, 7 weeks with my junior high kids. How oceans have a huge thing of shaping the climates. I introduced them this really cool website with Windy, and there's all sorts of things. Not only can you do like temperature, you can do wind patterns. You can actually do also ocean patterns, how they're flowing. And throughout that, in the teacher notes, it tells you when and where to like change these different patterns with our oceans and climate. Earth's uneven. Oh, this is just kind of, I'm also bringing in, I first start with when I'm shaping this is I'm really focused on the kids have this major misconception. So I start developing the model here with why is it so much warmer at the equator than at the poles? So we talk about basically climate, where we're talking about Earth's uneven heating, and we talk about direct and indirect with that. Um, yeah, with that part here. And then shift after we shift about why is the equator warmer? A lot of kids, like I'll have at least one or two lab groups, a quarter of the class talk about how they think that the equator is warmer because I think it's closer to the sun. So we just really I really spend like about like not only these two labs and a reading, spend about a week on that with my junior high kids. Then I move into another way that we have an imbalance with energy is heating land and water, where they heat up they heat up water and soil. And with that, then they heat it for 10 minutes with a heat lamp, and then they let it cool. And then you get this nice data here where they see that the land heats up much faster and the water almost stays the same. So I talk a little bit about Pacific heat capacity, but we're really just talking about with my junior high kids talking about is that land can just transfers energy in and out much faster than water. We can get in a little bit. I don't usually have this much time. This is fourth quarter, but we can get in. I usually try to bring in some climate graphs. And with they're really talking about, they're looking at different places around the world with latitude, how it impacts it, and then also coastal areas, how it impacts our temperature and precipitation with that. What are we doing with this one? Oh, ocean currents. Here's our ocean currents lab, where I feel like I should probably scroll further down into this to make a little bit more sense. But ocean currents lab is this, I have a jar with hot water and I have a jar with cold water. And I put some food dye. I have the kids put 5 drops of food dye of cold on one side, 5 drops of warm, and they start to see how they flow in relation to each other and start talking about density, talking about energy, talking about particle diagrams there. We have some readings here. And these readings really tie in all the major things, how we see the water flowing, oceans flowing the way they do, and also talking about the imbalance of temperatures that we have around the world. And then I have a midpoint assessment brought in during that point. So afterwards, you start talking about salinity. Um, this isn't the best diagram. I actually have a better one. I use density tanks. You can get them on Amazon for like $70 per one, but I have each group do it where there's a little divider in there. And then we just talk about salinity. They do a couple of mini tests where we'll do salt water and fresh water, and they see how they layer based on density. And then we'll do hot water and cold with that. And we're talking about how those things shape, which we'll build on later. There's a density layering one where I'll have hot water, hot fresh water, cold fresh water, salt, hot, stop cold, and they start making predictions of how they think it'll layer and try to get them to layer correctly and trying to not get them to mix. So with that. So then we get into the wind currents lab. I'll be honest, this one is a very messy lab where I'm going to scroll down. Actually, I feel like I'll make more sense if I'm in the teacher notes. Where am I at? Yeah, here's our land versus water, our hot and cold water. We see that. Here's our density I was talking about. Yeah, they use clay here. I forgot the name. I think I have in the teacher notes. Yeah, I gotta put in the teacher. I'm gonna make notes here. The type of clay. You don't want to make it soluble where it'll just be a big mess. There's types of clay that just it's not soluble, so it won't dissolve in the water. They make an island, and then test three, they make an irregular shape. And you put pepper in there, and then you have them just use straws to blow through there and just see what types of patterns flow through there. And the big thing they start to see then out of this is wind patterns have a bigger impact on moving ocean currents rather than hot and cold. Like they see before that warm and cold water will shape the currents, but they also see that wind patterns have a bigger influence on that. Again, there's a reading with that. We start getting into the Coriolis. I'm lucky where we have these fancy globes where we can actually draw on there, and we start to see how the Coriolis affects our wind patterns here. With that, and they actually draw on it. You don't have to have these fancy ones. I have the link to where you can buy them. But you can also just, I've seen it done with also with just balloons where they move it and they move it in like, the way the earth rotates, and they'll see how it goes clockwise and counterclockwise in the different hemispheres with that. After we talk about that, we start talking about El Nino and how that shifts our big level shift. There's a free website here with that and how it shifts the ocean currents with that. I'm trying to think what else here. I don't know. Oh, air pressure. Okay, yeah. So I want to like start talking about air pressure here, but that comes up in the weather and storms. It's really up to you. I'm not saying it's right or wrong, actually. But with that, yeah, air pressure. I want to start bringing this up here, but that I have that come up actually in the weather and storms here. So at the end, they make a big summary board and they review, and there's an assessment here of, okay, like what are the major factors that shape the Earth's climate and how oceans are have a big impact on that. And they're starting to see how coastal areas are with that. I'm saying a lot. I'm not used to talking this much, even with my kids. I'm usually having the kids doing activities and me just, using a modeling structure, not telling them if they're right or wrong. If anyone has any questions about this or anything they would change, I would totally fine by me. Please let me know. Okay. And if you have any questions about these activities or anything afterwards, please let me know and I can definitely always get back to you also with that.
I have a
Sorry.
question.
Yeah.
So in the 2016 curriculum, my memory is that they usually start out with telling you what NGSS standards it relates to. I don't see that on this one. Is there any? Do you have any of that anywhere? And
Do you want the DCIs?
well, I'm trying to match up because I'm in Arizona and we have our own unique. So I'm just trying to just making sure I get a connection back to getting the connection back to standards.
Yeah,
But
so when I NGSS three-dimensional learning, right? I can send you, and I'll also put this in the email. So three parts to three-dimensional learning, of course. So there's the DCIs that I could put in an email to you, like here's the concepts that we're covering. Um,
mhm,
to me, the science and engineering practices, and everyone's like, how are you doing three-dimensional learning? And actually, I could actually pull up someone made a really nice diagram for how we're doing the science and engineering practices in a modeling classroom. And I always say, if you're doing modeling instruction, we're basically doing them all the time in our classrooms with
mhm.
it. And it's just throughout the modeling cycle and a modeling lesson. So that's part one. Part two, again, is the DCIs. What content are we teaching? And then part three, and I'll put in there, then I have a nice breakdown of a matrix of the um, cross-cutting concepts. And when you're looking at this matrix, it's really nice and convenient where it basically these concepts just come up organically, where it's energy, structure and property of matter, all these
Okay.
things, they're just randomly coming up in the activities throughout it. So, and this is where when I always try to talk to my colleagues about doing NGSS in a classroom is I'm not stopping and looking at a lesson and being okay, like, okay, well, which one am I covering? Which one of my DCIs am I covering? Which one of these? Like DCIs, I know what I'm covering when I'm teaching the unit, when I'm planning the unit. Modeling classroom, we're doing the science and engineering practices daily. And then those other like the cross-cutting concepts, like they're coming up organically throughout in all the activities that we're doing, whether I'm doing a lab with graphing, we're doing a simulation looking for patterns, like those things just come up naturally, I feel like when you're doing it. I don't know
Yeah,
if that,
we
yeah.
just have some unique things related to content, and so sometimes it's just trickier to match things up. That's fine. That's fine. I'd like to just see what you were talking about. Thank you.
Yeah, I will send you the graphic organizer for science and engineering practices, and I'll also send you the matrix in the email afterwards. I hope I hope that helps you what you needed. Okay. The last one is just weather and storms. And again, I think the big thing here is our beginning ideas is which one did I, yeah. Why is it so hard to predict the weather? And with that, then again, I have this an elicitation where I have the kids start with their ideas here. I then have them move into this lab. These are one of my most favorite labs to do with the kids all year. These convection tubes. They're a little pricey through Carolina Science. I have them attached in the teacher notes. I think you can make these cheaper. I'm going to start here. So we did our elicitation. Now we do this heating and cooling lab, and what we're trying to get out of this now is how hot air rises and cool air sinks. And these are the convection tubes I'm talking about. They're a little pricey. You put a thermometer on the bottom, and then they have these thermometers on the inside. These black things are just a thermometer up top in the middle. You can buy those really cheap on Amazon. They light up a certain color, whatever temperature there is. And all we want to see is how warm air rises and hot air colds, and we're tying it back into there. Yeah, again, this is just kind of like a diagram version of that. We have a reading with that. Then I start talking about, okay, warm air rises, cold air sinks. Now I have them with these, then I have them do this humidity moisture lab where we put them in different jars, and the jars tell you what to do. They're either putting hot or cold water, they're putting smoke or no smoke in there. And then we're talking about up top, is there cold or is there no ice? And they start to see then that the one with hot water, smoke, and ice up top really makes it super cloudy, and you'll see the precipitation water rolling down the sides, where we're establishing some of our key vocabulary there that we have with weather and storms. Um, yeah, these are just kind of pictures of the samples of the kids' work. Talk about energy bar charts here. Um, it bothers teachers, and I've had a lot of people say this before, is like they get upset. It's like, I'm not talking about phase energy yet. Just doing thermal energy with my kids is enough with this. It's really complicated for them. And the phase energy, I always say, it gets added to their model when they go to high school. Is it right that we leave it out, bleed it out? Not no, but it's kind of like how I teach force diagrams, where I don't get as complicated with the force diagrams as the high school teachers do. We get simple. We talk about balance and unbalanced forces, but here I keep it a little simpler, just talking about thermal energy at this point. And then also through here, they're referencing these particle diagrams again throughout the unit. Next thing we start talking about here is it's a free, yeah, oh, page number 4. It says it's not found, but if you type in like, yeah, if you go to like, I usually have them go somewhere in Hawaii, and then from here, then is they're analyzing, go to the 10-day, building on more about weather data. They're talking about temperature, they're talking about precipitation, and we're starting to tie in then air pressure here, where if you do the customize, and again, all this is in the teacher notes, is they start seeing a pattern with precipitation and with air pressure. Forgot which ones we click here. I'm sending a lot of information, but yeah, when they start talking about it, like, oh, so when the pressure drops, the chance of precipitation rises, and we start seeing a pattern here that's going to continue to build throughout the unit. They're going to do a sorry, what's that? Oh, sorry. So after they see this pattern with the worksheet, they start seeing there's this lab. I have the YouTube video how to do the lab, but you put hot water in a 2-liter bottle or any sort of bottle, and then put a little bit of a smoke stick in there, a pump stick. I have where you can buy those, but they're really cheap. And then you cap it, and they start to see then where it's low pressure, unsqueezed, it's cloudy, and when you squeeze it, high pressure, it gets clear. And we're talking about an energy transfer that's forming that then. So you start to see that there's a system with that. They start doing a simulation where they use high pressure and low pressure and see where it's cloudy. This is a Gizmos one. Again, if you it's a paid subscription though. I'm not sure if you don't have that, how else you could supplement that. There's obviously free worksheets and things out there, but yeah. We come back to those convection tubes before, where they saw before, where warm air rises and cold air sinks. This one's cool now, where when you put the punt stick in here, the smoke stick, they'll start to see that the air is going to rush from where the cold surface is over to the hot. And we're talking about pressure systems. And it's tricky with pressure, but we're talking about here then is that there's less air pressure in the warm one because the particles are less compact, so it's rising. So it has this really strong jet stream that when you put a flashlight in here, you can actually see it come over. It's a lab that the kids really like to do. So we started talking about building us all into breezes, land breezes, and sea breezes, where we build off of this convection tube here, and we start talking about air masses and apply it in the worksheet here. And then that finally leads us into a storm simulation. This one's free. It's pretty cool, where you can make different storms, like different factors. So like the high air temperature, make it cold, low temperature, make it really warm, make them humidity. And if you go, it'll start to form it. And there's some different variables here that you can make for different level storms. So, and it explains the process. There's a worksheet. All these things I obviously always have activities or worksheets to go with it too. So, and that is about it. Um, that is, I'm not sure if anyone has any questions or anything. That's about it. I just wanted to walk you through them. And if you have questions, I know I have, I'm sick to know what to email out afterwards. I'm going to email a survey, but I'm also going to send you some of the things that people have questions about. I just want to let you know, here's some things. We have a sneak peek for some upcoming, uh, upcoming workshops. And Sue, I don't know if you want to speak a little more of this or not, but just kind of gives you more like information about some of the major workshops that we have in the summertime. So
Yes, if I could just take 30 seconds. These, we're calling them sneak peeks. They're another word might be an appetizer or a little, just a little glimpse into what would it be like to actually take a modeling workshop in any one of these topics. And so each person volunteered to do this. They chose one or maybe two activities, and they'll do them in student mode, and then they'll do them in teacher mode as well, including the whiteboarding and the discourse, and just give people that are not familiar with modeling a glimpse into what do you do at a modeling workshop? What would it be like to take a modeling workshop? We're trying to really push these out to people that are not modelers and build more community, build for some more potential workshops this summer. So if you want to share these links, they're all free. They're 60, 70 minutes long. The next one is on Saturday, but other ones are usually on weeknights. So yeah, please share these out to, your administration. If they're not up to up to date on what is modeling. If you would like to host a workshop, I would love to talk to you about hosting a workshop at your location. So anybody here interested in having George come and do a workshop this summer, let me know. And we'll try to organize that.
yeah, and like like speaking on the middle school, like what I just went through is a lot. And what we do as teachers is we go through every curriculum as students, and then as we go through these activities, we then talk about teacher mode. Why we did things the way we did, what we could do better, other questions that we have as teachers that we have throughout all of it. And that's where we really start the things to make sense and for you to bring back into your classroom. Like today, it's just like a real quick overview, but yeah, by all means, it's just hopefully it's a resource that you can use with your kids. But the workshops is where we really start to make sense of these things. Like I went through the master's program at Arizona State, and it was 2 years of going through classes with the natural science program, where it really took me about 2 years to really understand how to use modeling in classroom. The workshops are usually 2 weeks, and it gives you such a better idea. I don't think you can really do modeling well in just a quick snapshot like this. Does anyone have any other questions or anything, or anyone want me to put in the email I'm about to send out afterwards? Thanks everyone for your time today. It's nice meeting everyone. By all means, when I send you an email, if you ever want to stay in contact or email questions about anything about modeling instruction, that's what I like to do. So thanks again for everyone's time. So.